Kirk Bresniker is the Vice President, Chief Technologist, and Fellow at the Business Critical Systems Unit at HP. And he and his team played a vital role in defining HP's mission-critical offering. And I think that he has a unique perspective on what infrastructure and the cloud are going to look like. So welcome, Kirk.
Good morning, everyone. I think I was the only one in my row who raised his hand when Jim said who does hardware in the beginning. So I'm your token hardware engineer for the day, and we'll talk about the infrastructure and specifically where we at HP see the infrastructure evolving and what we're learning and platforms and kind of platforms that we'll see coming out over the next couple of years that are going to be powering the underpinning of all of the software stacks that you're going to be going through. I think it's interesting for me, my son is going through high school geometry right now. So first time you end up having to sort of go through logical thinking, and we talk about conditionals, if, then, converse, inverse, and then we get to necessary and sufficient. And I think part of what we'll talk about today is that I'll be talking about what I think is the necessary piece. With what Jim showed when he saw all those mobile devices. The infrastructure, the hardware, the atoms, they are necessary. And I think that we'll talk about how we find we are optimizing them and what we actually think is required to underpin global infrastructure to take on some of the emerging challenges and opportunities we see in business in the world today. But it's only necessary. It's not sufficient. The piece that will make it sufficient, the if and only if, is the software layers that are sitting above. And everything we had at the panels, all we talked about today, I have emerging models, the freedoms, the capabilities that we express in those stacks, I think is really what is necessary to layer on top. Also, sort of by way of introduction, business critical systems, we provide the platforms that have traditionally been proprietary. They've been the Unix platforms. They've been our non-stop platforms, our BMS platforms. But what we'll hear today is that we are driving more and more of those. As our panel discussed, they have to be cognizant. They have to embrace open development models in order to really meet that necessary condition of underpinning global infrastructure. I also, as a matter of fact, host several other HP-wide technologists. I think many of you know Vidal Garby, who works on my staff. He's actually not here today, partially because he finally made the work-life decision that the HP early retirement package we offered this year was too enticing for him to leave out, but also because the Linux Foundation failed to coordinate their schedules with high-energy rocket launch events that are happening this week in Kansas. So we'll wish Vidal good flights this week as he and his family have some exciting launch events, launching him into the next phase of his career, as well as launching some high-powered rocketry. Also on my staff I have Dong Wei, who many of you may know from the UEFI forum. So having Dong and Vidal on one staff reflector can sometimes be a very interesting thing, especially because both of those guys cannot let the other one have the last word on our staff reflector. So we host some pan-HP technology things in my team as well. So a little bit about HP. I mean, we all know these numbers. I think mainly what I wanted to show here is that despite all of some of the recent press events, HP is going to go out of business in 6 years. They know what they're doing. We are one of the largest infrastructure providers in the world. We're making a PC, 2 PCs every second, 2 printers every second, a server every 15 seconds. Servers near and dear to my heart. Of those servers, we figure between 25 and 50 of those percent of those servers end up running Linux. We can't always tell exactly what they are going to run because sometimes the customers order them without operating system. Our naive assumption is if you order a platform HP without an operating system, you're going to be running some variant of Linux on it. Also, even if you order it without Linux, you might end up running Linux either directly or in virtual machines. So we understand about infrastructure, and really that's what we think that we're doing very well. In terms of the cloud, we heard a lot from the panel today. This is this emerging model, the capabilities, and it's very enticing. It's, you know, there isn't a CIO, a CEO that I end up going out and talking to around the world. They all know they know they need to be aware. They know they need to be aware about the open source. They know they need to be aware about collaborative development environments. And they also know that even if they say no, that their business, their lines of business are exploring this on their own. And they want to know, they will always start asking us, what should we do? What's your advice? How do we begin to understand the capabilities that the cloud is going to offer to us? How do we understand how to respond? Because much as we heard the panel today, there are concerns. There are concerns about, is my cloud service provider obeying the data privacy regulations in my jurisdiction? Does my industry regulation allow me to choose any vendor? What is the end user agreement? What do I know is going to be the long-term repository of my data? Am I going to be satisfying my risk profile as I try to embrace this? HP, we're driving hard on this in hosting these environments and beginning to help our customers walk through some of these questions. HP technology every day. Almost every time you hear in North America you swipe your card or you turn on your cell phone and authenticate against your network, you're hitting an HP platform. And increasingly, again, open source, Linux, they're all pieces of this equation. But I think if I look forward and I think of the challenge that we have that are coming out now, how are we going to have coordinated intermodal transportation? What are we going to do when the majority of people in the world live in mega cities? How are we going to have retrofit intelligent power grids in North America, Europe, and developed Asia? How are we going to deploy intelligent power grids in South America, Africa, and developing Asia? When I think of these grand challenges, you know, for me, open source, the collaborative development model, the cloud, that diversity of thought, of opinion, of approach, of opportunity, that really plays all the strengths in the open source development model. And for us as an infrastructure provider, we are working very hard to understand what is the infrastructure pieces that need to fit underneath that to allow the speed of change that has to occur if we're going to solve these grand challenge problems happen in a way that will be suitable globally. So in our infrastructure teams, we end up providing all the aspects of the infrastructure. We do the storage piece, HP storage. We do the servers, business critical servers, industry standard servers. We do the networking from HP networking, power and cooling, our EcoPod, our mission critical infrastructure and data center build teams, and our management software layers that go underneath. My peers and I, all of the chief technologists of each of these respective divisions, are expected to produce products that are number one, maybe number two in their category, each is individual categories. But we're also expected, and we're measured against the way in which these pieces interact as infrastructure, as intelligent infrastructure underneath. And that is where we think that we're adding some specific value that is going to enable new and different modes of deployment. So for us, from servers, storage, networking, these next generation infrastructure pieces are the elements that we believe will enable the OpenStack, the software layers, the collaborative development model to be deployed at the scale to handle the kinds of challenges that our customers are facing. We have three specific projects. These were announced last November. And really what they speak to are what we think are the directions and the innovations that infrastructure needs in order to be deployed at the scale that is necessary to solve global problems, at the speed at which business and cultural opportunities are presenting themselves. Project Moonshot, Project Odyssey, Project Voyager. You can see we chose as a theme American space exploration names. And that was intentional. because much as we feel that the space program here in the States allowed us to drive technology and opportunity together in a unique way, we see that we're also on the same cusp. And again, for us, being the infrastructure piece, the necessary piece, what we're really trying to do is buoy up and provide the underpinning for that collaborative development model and the economics and the ecosystem around it to take flight. So Project Moonshot. We actually have a demo in the vendor room, and you can go and see Project Moonshot. But really what this is realizing and now having the experience of selling infrastructure to massive scale out, massive internet properties. We learn about what would it take if we were to start over, if we were to start again and say, if I'm going to be deploying 10,000, 100,000, a million servers, and I knew the algorithm, I knew the application that they would be deployed on ahead of time, what would I do to optimize? What would I do? What would I take from the server box? What would I cut away? What would I replicate? What would I fold away? What would I standardize? What would I centralize in order to be as efficient on that deployment as possible? And you can see some of the numbers down here. Again, these are for specific applications. If you are a general purpose user, if you don't know what you're going to be running, then Moonshot is not necessarily the platform for you. But if you know, if you have the intelligence, if you have, almost most importantly, source code control, if you can optimize, if you can modify, then this could be a potentially very rewarding infrastructure piece for you to understand. 89% less energy, 94% less space, 63% less cost, 97% less complexity. And for me, almost as important, the diversity in the elements, diversity in microprocessor architecture, diversity in distribution, novel software made up with optimized hardware. Project Odyssey. This is actually the piece that my team is responsible for. What we're trying to do in Project Odyssey is we have fundamentally, over the last 10 years, modified our hardware deployment, our hardware design philosophy, so that we have commonality. Industry standard servers, proprietary hardware, it's all been folded together. It's all essentially the same pieces, the same bits and pieces used over, whether it's going into the skinniest little half-wide, half-high, Reliant scale-out blade, or the Superdome 2 scale-up platform. All the same hardware pieces there. What we want to create for mission-critical Linux is the same user experience that we have in the proprietary world. And that's only a piece of that, is that hardware layer. We've already sort of done that piece. You can see that's the bottom of the stack, mission-critical servers. But there are all the layers above, mission-critical system software, the embedded environments. Usually it's in this case, embedded Linux as an embedded environment. Mission-critical Linux. Taking technology, taking ideas and concepts, whether they're in test or development or actual technology, driving those in a collaborative way, in the right way, into the open source development communities. Mission-critical infrastructure software layered on top to do things like high availability, to do things like high available clustering. And finally, mission-critical services engineered, actually, because this is setting up a services organization that can respond to the way that the mission-critical customers demand, is an engineering effort of itself. Setting all that up, creating that analogous experience. I was at a major carrier, telecommunications carrier here in the United States, and they love Linux. They use it all the time. But they have a mindset, they have a ceiling on Linux. It can only go this high. Because in their mind, to move to Linux on their massive scale-up, big iron applications means they have to re-engineer. They have to spend money up front to re-engineer, possibly not always successfully. And they've had both successes and failures at re-engineering for massive scale-out. But they know they're going to have to spend money up front to re-engineer. Therefore, they figure, well, I'm going to have to buy cheap hardware. I've already re-engineered for scale out, for availability and application. I'm going to have to buy the cheapest hardware possible. And I'm therefore going to relegate Linux to the scale-out environment. And really what we're trying to do with Project Odyssey is say, no, we want to extend. We want to drive mission-critical Linux so that you can have high availability single system. So for those problems which are not yet solved in a scale-out way efficiently, that you can have that same experience, you can have that same confidence in a high scaling, very low latency, very large memory, single system image with Linux, and know that all the other pieces are going to be there. And finally, Project Voyager. As we've deployed massive scale out, we've worked with customers who purchase in lots of 10,000, 20,000, 100,000 units at a time, who end up buying, entire production runs of components. You learn a lot about what can go wrong in a supply chain. And Project Voyager represents our knowledge that we've gained from these interactions. And what should you do? What should you do to the hardware, to the systems, so that you can operate a collection of systems as a single system? What could you do to add telemetry, to add memory, to add history, provenance, so that you can go into a massive scale-out environment and very quickly establish where were all those DIMMs manufactured? Is there a correlation? I'm seeing an event here. I'm seeing too much heat. I'm seeing too many failures. How do I correlate that back to the manufacturing process? How do I keep these massive systems, these massive engineered systems running at peak efficiency? How do I correlate all this information? So that's what Project Voyager is doing. So, on to cloud. Cloud leadership, we have some of the most trafficked websites, some of the most popular social media elements, some of the largest providers are adapting to our cloud infrastructure already. And I think as we heard some of the talk on the panel today, people are approaching this through a spectrum. We still have customers who want to stand up traditional systems. They want to stand up private clouds. They may have data concerns. They may have regulatory restrictions that prevents them from fully utilizing public cloud. And then we also have new emerging companies who want to take advantage of the cost, the agility, all the capabilities that is now giving them incredible access to storage, to cycles, to compute on an ad hoc basis. But they also are trying to think of what happens next. What happens if I'm successful? Do I still want to be being charged every month? Will I reach a point at which I should consider moving from public provider and stand this up on my own? At some point, should I be looking to transition? And part of what we've tried to do is create a set of offerings on the infrastructure side that allow you to utilize this in the public environment and then decide, okay, at some point I want to take this internal, I want to be running it on the same stuff. I want that to be a very smooth process. And we also have the other side. I'm a very traditional company. I'm going to stand up my public cloud, my private cloud, and I want it to be there. And then at some point, I'm going to want to burst out, and I'm going to go out for extra resources. And I want to begin to mature my understanding, match my risk profile, match my understanding and my capability and my experience level. And so that's where we think we have an advantage in providing one set of offerings that can span that entire range. Now, what pins this together and what allows us to make all of these offerings is OpenStack technology, open web-based APIs, a dynamic community, a dynamic ecosystem. Again, for me, biodiversity is what makes this model successful, that diversity of thought, of approach, of opportunity, and knowing that we have this model, this collaborative development model that can underpin all of it. Accelerating the time to market, private, public, federated developments, and active involvement with the governance boards and design summits. That is really what we see as beyond the necessary and into the sufficient. What will enable us to deploy cloud across the entire range of customers that we have. Again, from the little startup that is going to be taking advantage of these elastic services, all the way up through the very risk-averse, very traditional environment of customers, but that know they have to understand this, they have to embrace this, they have to factor this into their decisions. So our public cloud offering, of course, we have HP systems as the underpinning, as infrastructure as a service. We get a pretty good discount in using them ourselves and standing this up. But then we have the platforms as a service, the software as a service, our partner ecosystem, and that hybrid interoperability, the ability to use both internal and external. We have our portfolio of services, block services, file service, object services, compute services, everything that you would expect. And again, you can create this as a private cloud. You can burst out to the public cloud. You can go directly to public cloud providers who are using the same infrastructure. We're also offering some of our software resources in our cloud environments. So data analysis with Vertica, data archiving with Autonomy, as well as partner programs. So for us, yes, I will freely admit, I am a person who makes metal boxes. I've been doing it for 25 years, metal boxes with printed circuits inside. You know, that's, again, for us, that is the necessary part. We think we do a great job, but that's the necessary part. What really raises us up to answer the new and dynamic challenges that we're seeing for global economic development, for energy and resource management. All that we believe is going to be coming from the cloud, from these engagements, and our infrastructure in cooperation with open collaborative development and software models on top is what's going to enable that entire range of customers to be able to access and capitalize on collaborative development. With that, I thank you, and I wish that everyone have a great conference this week.